Welcome back. It's 10 a.m. so I still have a long day. Let's reading about the old fighter jet. This old F-104 Starfighter. 10 a.m. Then I will make a video on my language. After this I have my reading list. And I get my Danish pension in 2 days. So I just like to relax and do nothing, reading, relax, watch Netflix, take a walk. So let's do that. But that's a long one, that's a very long one, this one.
Lockheed F-104 Starfighter. The Lockheed F-104 Starfighter is an American single-engine, supersonic interceptor. Created as a day fighter by Lockheed as one of the Century series of fighter aircraft for the United States Air Force, USAF, it was developed into an all-weather multi-role aircraft in the early 1960s and extensively deployed as a fighter bomber during the Cold War. It was also produced under license by other nations and saw widespread service outside the United States. After interviews with Korean War fighter pilots in 1951, Lockheed lead designer Kelly Johnson chose to buck the trend of ever larger and more complex fighters to produce a simple, lightweight aircraft with maximum altitude and climb performance. On the 4th of March, 1954, the Lockheed XF-104 took to the skies for the first time, and on the 26th of February, 1958, the production fighter was activated by the USAF. Just a few months later, it was pressed into action during the Second Taiwan Strait crisis to deter the use of Chinese MiG-15 and MiG-17 fighters. Problems with the General Electric J-79 engine and a preference for fighters with longer ranges and heavier payloads initially limited its service with the USAF, though it was reactivated for service during the Berlin crisis of 1961 and the Vietnam War, when it flew more than 5,000 combat sorties. 15 NATO and Allied air forces eventually flew the Starfighter, many for longer than the USAF. In October 1958, West Germany selected the F-104 as its primary fighter aircraft. Canada soon followed, then the Netherlands, Belgium, Japan, and Italy. The European nations formed a construction consortium that was the largest international manufacturing program in history to that point. In 1975, it was revealed that Lockheed had bribed many foreign military and political figures to secure purchase contracts. The Starfighter had a poor safety record, especially in Luftwaffe service. The Germans lost 292 of 916 aircraft and 116 pilots from 1961 to 1989, its high accident rate earning it the nickname Widowmaker, from the German public. The final production version, the F-104S, was an all-weather interceptor built by Air Italia for the Italian Air Force. It was retired from military service in 2004. As of 2025, several F-104s remain in civilian operation with Florida-based Starfighters Incorporated. The Starfighter featured a radical design, with thin, stubby wings attached farther back on the fuselage than most contemporary aircraft. The wing provided excellent supersonic and high-speed, low-altitude performance, but also poor turning capability and high landing speeds. It was the first production aircraft to achieve Mach 2, and the first aircraft to reach an altitude of 100,000 feet, 30,000 m, after taking off under its own power. The Starfighter established world records for airspeed, altitude, and time to climb in 1958, becoming the first aircraft to hold all three simultaneously. It was also the first aircraft to be equipped with the M61 Vulcan autocannon. Development, edit. Background and early development, edit. Main article, Lockheed F-104. Clarence L. Kelly Johnson, Vice President of Engineering and Research at Lockheed's Skunk Works, visited USAF air bases across South Korea in November 1951 to speak with fighter pilots about what they wanted and needed in a fighter aircraft. At the time, the American pilots were confronting the MiG-15 with North American F-86 Sabres, and many felt that the MiGs were superior to the larger and more complex American fighters. The pilots requested a small and simple aircraft with excellent performance, especially high speed and high altitude capabilities. Johnson started the design of such an aircraft upon his return to the United States. In March 1952, his team was assembled. They studied over 100 aircraft configurations, ranging from small designs at just 8,000 pounds, 3,600 kilograms, to large ones up to 50,000 pounds, 23,000 kilograms. To achieve the desired performance, Lockheed chose a small and simple aircraft, weighing in at 12,000 pounds, 5,400 kilograms, with a single powerful engine. The engine chosen was the new General Electric J79 turbojet, an engine of dramatically improved performance in comparison with contemporary designs. The small design, powered by a single J79, issued temporary design number L246, remained essentially identical to the prototype Starfighter as eventually delivered. Lockheed designated the prototype Model 083. Johnson presented his new fighter concept to the United States Air Force on the 5th of November, 1952, and they were interested enough to create a general operational requirement for a lightweight fighter to supplement and ultimately replace the yet-to-fly North American F-100. 3 additional companies were named finalists for the requirement: Republic Aviation with the AP-55, an improved version of its prototype XF-91 Thunderceptor, North American Aviation with the NA-212, which eventually evolved into the F-107, and Northrop Corporation with the N-102 Fang, another J-79 powered entry. Although all 3 finalists' proposals were strong, Lockheed had what proved to be an insurmountable head start, and was granted a development contract on the 12th of March, 1953 for 2 prototypes. These were given the designation XF-104. Work progressed quickly, with a mock-up ready for inspection at the end of April, and work starting on 2 prototypes soon after. Meanwhile, the J-79 engine was not ready. Both prototypes were instead built to use the Wright J-65 engine, a license-constructed version of the Armstrong Siddeley Sapphire. The first prototype was completed at Lockheed's Burbank facility by early 1954 and first flew on the 4th of March at Edwards AFB. The total time from contract to first flight was less than 1 year. Though development of the F-104 was never a secret, only a vague description of the aircraft was given when the USAF first revealed its existence. No photographs of the aircraft were released to the public until 1956, even though the XF-104 first flew in 1954. At the April 1956 public unveiling of the YF-104, the engine inlets were obscured with metal covers. Visible weapons, including the M61 Vulcan cannon, were also hidden. Despite the secrecy, an artist's rendering of the yet unseen F-104 appeared in the September 1954 edition of Popular Mechanics that was very close to the actual design. The prototype made a hop into the air during taxi trials on the 28th of February 1954 and flew about 5 feet, 1.5 m, off the ground for a short distance, but this was not counted as a first flight. On the 4th of March, Lockheed test pilot Tony Levi flew the XF-104 for its first official flight. He was airborne for only 21 minutes, much shorter than planned, due to landing gear retraction problems. The second prototype was destroyed several weeks later during gunfiring trials when the hatch to the ejector seat blew out, depressurizing the cockpit and causing the pilot to eject in the mistaken belief that a cannon mishap had crippled the aircraft. Nevertheless, on the 1st of November 1955 the remaining XF-104 was accepted by the USAF. Further development, edit. Based on the testing and evaluation of the XF-104, the next variant, the YF-104, was lengthened and fitted with a General Electric J79 engine, modified landing gear, and modified air intakes. The YF-104 and subsequent models were 5 feet 6 in, 1.68 m, longer than the XF-104 to accommodate the larger GE J79 engine. The YF-104 initially flew with the GEX J79 GE3 turbojet which generated 9,300 pounds of dry thrust, 14,800 with afterburner, which was later replaced by the J79 GE3 with an improved afterburner. 17 YF-104s were ordered by the USAF on the 30th of March 1955 for further flight testing. The first of them flew on the 17th of February 1956 and, with the other 16 trial aircraft, was soon carrying out aircraft and equipment evaluation and tests. On the 1st of May 1957 one of the prototypes was destroyed when the ailerons malfunctioned, resulting in the aircraft tumbling wildly. The pilot ejected safely. Lockheed made several improvements to the YF-104 throughout this testing period, including strengthening the airframe, adding a ventral fin to improve directional stability at supersonic speed, and installing a boundary layer control system, BLCS, to reduce landing speed. Problems were encountered with the J79 afterburner. Further delays were caused by the need to add AIM-9 Sidewinder air-to-air missiles. On the 28th of January 1958, the first production F-104 to enter service was delivered to the 83rd Fighter Interceptor Wing. Redesign for NATO, edit. In response to a 1957 German air staff paper asking for a single aircraft to fulfill its fighter bomber, and reconnaissance mission requirements, Lockheed redesigned the entire airframe, including 96 new forgings, additional skin panels, and reinforced landing gear with larger tires and improved brakes. The proposed F-104G, for Germany, Super Starfighter featured a more powerful J79-11 engine, a larger tail with powered rudder, the same used on the two-seat F-104B and D, improved blown flaps with a mode for improved maneuverability, electric de-icing equipment for the air intake inlets, and a larger drag chute. Avionics were improved as well, primarily with the Autonetics F-15 ANASA, North American Search and Range Radar, Multimode Radar and the LN-3 Inertial Navigation System by Litton Industries, the first such system to be placed into operational service. Altogether, these changes increased the amount of external weapons that could be carried to 3,000 pounds, 1,400 kilograms, and also allowed the aircraft to fulfill the NATO requirement of carrying a 2,000-pound, 910 kilograms, special store nuclear weapon under the fuselage. Belgium, the Netherlands, and Italy selected the F-104 soon after as well, and the 4 European nations set up 4 production groups to jointly manufacture the F-104G under license. RB Mindschaft, ARG, South consisted of Messerschmitt, Heinkel, Dornier, and Siebel. ARG North comprised Hamburger Flugzeugbau, Focke-Wulf, and Wasserflug in Germany, as well as Fokker and Aviolander in the Netherlands. The West Group was made of Subca and Avians Ferry in Belgium, and the Italian group was formed of Fiat, Macchi, Piaggio, Sicca, and SIAI Marchetti. The 4 groups were contracted to manufacture 210, 350, 189, and 200 F-104G aircraft, respectively. In addition, 1,225 J-79 turbojets were also produced under license by BMW in Germany, Fabrique Nationale in Belgium, and Alfa Romeo in Italy. Canada, who had also chosen the Starfighter to fulfill its NATO obligations, delivered 121 sets of wings, aft fuselages, and tail assemblies built by Canadair to Europe, while it constructed 200 CF-104s with Orindar-built engines for the Royal Canadian Air Force. Later the two would also build an additional 110 MAP-funded F-104Gs destined for Europe. Lockheed for its part built 191 two-seat trainers for both Europe and Canada, as well as supplying spares and technical support. The multinational consortium formed a central coordination office named NASMO, NATO Starfighter Management Office, in Koblenz, Germany, which succeeded in achieving a high level of standardization and cooperation. This was evidenced by an F-104G being assembled in April 1963 at Erding Air Base in Germany, consisting of components constructed in all 4 European partner countries. However, this central coordination resulted in long delays in implementing needed modifications and upgrades. Some of the modifications that were proposed during this time, mainly from the Joint Test Force at Edwards AFB in California, were the installation of an arrestor hook, a standby attitude indicator, and the emergency engine nozzle closure system. In all, 2,578 F-104s were produced by Lockheed and under license by various foreign manufacturers. Design, edit. Airframe, edit. The Starfighter's airframe was all metal, primarily duralumin with some stainless steel and titanium. The fuselage was approximately 2.5 times as long as the airplane's wingspan. The wings were centered on the horizontal reference plane, or along the longitudinal centerline of the fuselage, and were located substantially farther aft on the fuselage than most contemporary designs. The aft fuselage was elevated from the horizontal reference plane, resulting in a lifted tail, and the nose was drooped. This caused the aircraft to fly nose up, helping to minimize drag. As a result, the petard tube, air inlet scoops, and engine thrust line were all canted slightly from centerline of the fuselage. The F-104 featured a radical wing design. Most jet fighters of the period used a swept wing or delta wing, which balanced aerodynamic performance, lift, and internal space for fuel and equipment. The Lockheed tests determined that the most efficient shape for high-speed supersonic flight was a very small and thin, straight, mid-mounted, trapezoidal wing. Much of the data on the wing shape was derived from testing done with the experimental unmanned Lockheed X-7, which used a wing of a similar shape. The leading edge of the wing was swept back at 26 degrees, with the trailing edge swept forward by a slightly smaller amount. Lockheed F-104 The new wing design was extremely thin, with a thickness-to-chord ratio of only 3.36% and an aspect ratio of 2.45. The wing's leading edges were so thin, .016 in, 0.41 mm, that they were a hazard to ground crews. Hence, protective guards were installed on them during maintenance. The thinness of the wings required fuel tanks and landing gear to be placed in the fuselage, and the hydraulic cylinders driving the ailerons were limited to 1 inch, 25 mm, thickness to fit. The small, highly loaded wing caused an unacceptably high landing speed, even after adding both leading and trailing edge flaps. Thus, designers developed a boundary layer control system, or BLCS, of high-pressure bleed air, which was blown over the trailing edge flaps to lower landing speeds by more than 30 knots, 56 km per hour, 35 miles per hour, and help make landing safer. Flapless landings would be without the BLCS engaged, as flaps in the land position were required for its operation. Landing without the BLCS engaged was only done in emergencies and could be a harrowing experience, especially at night. The stabilator, fully moving horizontal stabilizer, was mounted atop the fin to reduce inertia coupling. Because the vertical fin was only slightly shorter than the length of each wing and nearly as aerodynamically effective, it could act as a wing-on-rudder application, rolling the aircraft in the opposite direction of rudder input. To offset this effect, the wings were canted downward at a 10 degrees negative dihedral, anhedral, angle. This downward canting also improved roll control during high-G maneuvers, common in air-to-air combat. The fuselage had a high fineness ratio. It was slender, tapered towards the sharp nose, and had a small frontal area. The tightly packed fuselage contained the radar, cockpit, cannon, fuel, landing gear, and engine. The fuselage and wing combination provided low drag except at high angle of attack, alpha, at which point induced drag became very high. The F-104 had good acceleration, rate of climb, and top speed, but its sustained turn performance was poor. A clean, no external weapons or fuel tanks, F-104 could sustain a 7G turn below 5,000 feet with full afterburner. Given the aircraft's prodigious fuel consumption at that altitude and relatively small fuel capacity, such a maneuver would dramatically reduce its time on station. Engine, edit. The F-104 was designed to use the General Electric J79 turbojet engine, fed by side-mounted intakes with fixed inlet cones optimized for performance at Mach 1.7, increased to Mach 2 for later F-104s equipped with more powerful J79 GE19 engines. Unlike some supersonic aircraft, the F-104 did not have variable geometry inlets. Instead, at high Mach numbers, excess air was bypassed around the engine. This bypass air also helped cool the engine. Its thrust-to-drag ratio was excellent, allowing a maximum speed well in excess of Mach 2. Available thrust was actually limited by the geometry of the inlet scoop and duct. The aircraft was capable of even higher Mach numbers if the aluminum skin of the aircraft were able to withstand the heating due to air friction. Furthermore, speeds above Mach 2 quickly overheated the J79 engine beyond its thermal capabilities, which resulted in the F-104 being given a design airspeed limitation of Mach 2. The engine consisted of a 17-stage compressor, an accessory drive section, an annular combustion chamber, a 3-stage turbine, and an afterburner. The most powerful version of the J79, the J79 GE19, was rated at 52.8 kN, 11,900 lbf, dry thrust and 79.6 kN, 17,900 lbf, with afterburner. Bleed air from the compressor's 17th stage was used for a number of purposes. The BLCS, cabin pressurization and air conditioning, hot air jet rain removal, fuel transfer, canopy and windshield defogging and defrosting, pressure for the pilot's anti-G suit, pressurization and cooling of the nose-mounted radar equipment, and purging of gas from the M61 autocannon. The accessory drive ran 2 hydraulic pumps, 2 variable frequency generators, the generator for the tachometer, and pumps for engine fuel and oil. Armament, edit. The basic armament of the F-104 was the 20mm, 0.79 in, M61 Vulcan autocannon. As the first aircraft to carry the weapon, testing of the Starfighter revealed issues with the initial version of the M61. The Gatling mechanism cannon suffered problems with its linked ammunition, being prone to misfeed and presenting a foreign object damage, FOD, hazard as discarded links were occasionally sucked into the engine. A linkless ammunition feed system was developed for the upgraded M61A1 installed in the F-104C. The M61A1 has subsequently been used by a wide variety of American combat aircraft. Open weapons bay of a German Air Force F-104G exposing the M61 cannon. The cannon, mounted in the lower part of the port fuselage, was fed by a 7.25 round drum behind the pilot's seat. With its firing rate of 6,000 rounds per minute, the cannon would empty the drum after just over 7 seconds of continuous fire. The cannon was omitted in all the 2-seat models and some single-seat versions including reconnaissance aircraft, with the gun bay and ammunition drum typically replaced by additional fuel tanks. 2 AIM-9 Sidewinder air-to-air missiles could be carried on the wingtip stations, which could also be used for fuel tanks. The F-104C and later models added a centerline pylon and 2 underwing pylons for bombs, rocket pods, or fuel tanks. The centerline pylon could carry a nuclear weapon. A catamaran launcher for 2 additional sidewinders could be fitted under the forward fuselage, although the installation had minimal ground clearance and so rendered the seeker heads of the missiles vulnerable to ground debris. The 2 F-104S variants added a pair of fuselage pylons beneath the intakes for conventional bomb carriage and an additional pylon under each wing, for a total of 9. Early starfighters were also capable of carrying and launching a single MB-1, Air-to-A Genie, rocket-powered nuclear missile using an extending trapeze launcher. This configuration was tested on a single aircraft but was not adopted for service use. However, NASA later used it for launching test rockets. Avionics, edit. The initial USAF starfighters had a basic RCAN /ASG-14 T1 ranging radar, tactical air navigation system, TACAN, and an AN/ARC-34 UHF radio. The AN/ASG-14 fire control system used a 24-inch, 610mm, pencil beam radar antenna with 2 independent sights, 1 optical and 1 infrared. Early versions of the radar had a range of approximately 20 miles, 32 kilometers, in search mode, with later models reaching up to 40 miles, 64 kilometers. The scan pattern was spiral, covering a 90-degree cone. Search mode was usable only above 3,000 feet, 910 m, due to ground return effects below that altitude. Track mode was usable within 10 miles, 16 kilometers, of the target, which narrowed the scan to 20 degrees and initiated a strobe sweep between 300 and 3,000 yards, 270 and 2,740 m, in auto-acquisition mode. The radar also had a third, receive-only mode useful for locking on 2 sources of interference from electronic countermeasures, ECM. In the late 1960s, Lockheed developed a more advanced version of the Starfighter, the F-104S, for use by the Italian Air Force. Similarly to the F-104G, Lockheed produced two main variants of the F-104S, an all-weather interceptor, Caccia Interceptor, CI, and a strike aircraft, Caccia Bombardier, CB. The CI variant received AFIR/NASAR F-15G radar with AIM-7 Sparrow guidance capability.